The beginning of Chapter 6 reviews what exponents are and how they work. Using an exponential expression, we have two things, a base and an exponent. So in this example, 5 to the third power, the base is 5 and the exponent is 3. Now what this looks like if we were to expand this is 3 factors of 5. And remember, the word factor refers to multiplication. So in the next example, 2/3 to the third power, our base is 2/3. Our power is 3. So that would just simply be 3 factors of 2/3. In the next example, our base is -2 and power of 5, and that's 5 factors of -2. Oftentimes we use exponents to condense expressions. So in these 6 examples, we're going to look at what the base is and how many factors of the base there are to tell us the power. So in sample A, we have the base of 4, and there are 6 factors of them. So this is 4 to the 6th power. In B, our base is -3. Our power is 3. So that's saying we have 3 factors of -3. In C, our base is 2/5. And we have 5 of those factors. So this is 2/5 to the 5th power. In D, our base this time is a variable, and that is x. And since there are 4 factors of x, that is our power. So we would simply write this as x to the 4th. In example E, notice we have 2 different bases. One is base 5 with a power of 2, and the second is base y with a power of 5. So we would write this as 5 to the 2nd times y to the 5th. And in example F, we actually have 3 bases here. The first base is 3, also with a power of 3 since there's 3 of them. Base of x with a power of 2, and a base of y with a power of 4. So we would write this overall as 3 to the 3rd times x squared times y to the 4th. The opposite of condensing the expressions is expanding the expressions. We do this to help us recognize future patterns that exist within exponents. So for each of these samples, I'm just going to run through them. We have 3 factors of 4. B, we have 5 factors of 2/3. In part C, we have 5 factors of -3. D, we have 5 factors of m. And for E and F, we actually have more than one base. In E, we have 3 factors of 2 times another 5 factors of x. And in part F, we have 4 factors of 5, 2 factors of x, and 3 factors of y. And notice all of these are just being multiplied together since they're all factors. On the back, now we're going to look at first expanding an expression and then simplifying. So in this first section, we call this looking for the product, which just means we're multiplying numbers with like bases. So in part A, we have a base of 2 to the second power and a base of 2 to the fifth power. So this is going to look like, I don't need the parentheses, I'm just using them so you can see how it relates to the original expression. But then once I've expanded it, I can simplify, and as you can see, I now have 1, 2, 3, 4, 5, 6, 7 factors of 2, making this 2 to the 7th power. In B, notice this is simply 1 factor of 3/4, so there's actually an invisible 1 exponent there. And then multiplied by another 2 factors of 3/4. So in total, I now have 3 factors of 3/4 and can write it using an exponent of 3. In part C, I have 2 factors of -4 times another 3 factors of -4. And that gives us a total of 5 factors of -4, making this -4 to the 5th power. In D, I have 3 factors of y times another 4 factors of y. In total, I now have 7 factors of y, making this y to the 7th. And remember, this occurs because everything is being multiplied. So that's why I say I have 7 total factors of y. Now in part E, notice 2x to the 3rd power would actually be written as 2 times 3 factors of x. Notice the exponent of 3 does not apply to the base of 2, but only to the base of x. And in 4x to the 4th, the same occurs where we just have 1 factor of 4, but then 4 factors of x. So as you can see, I now have a total of 7 factors of x, making this x to the 7th. But also, I can multiply the 2 and the 4, since order of multiplication doesn't matter, and 2 times 4 just simplifies to 8. In part F, I have 3 factors of 4, 2 factors of D, multiplied by 1 more factor of 3. Again, we could recognize this as an invisible 1 exponent to represent 1 factor, and then 4 factors of D. So I've got 2 different bases here. That gives me a total of 5 factors of 3 and 6 factors of D. I want you to take a moment, pause the video, and think about what connections can you make among the original expression and the final one. How are the exponents connected? What patterns do you see? So go ahead and pause the video now and take a look at each example. So if you weren't able to pick it out, notice that if we were to add the exponents of like bases, it ends up being the simplified exponent. So notice 2 plus 5 equals 7, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 4 equals 7, 3 plus 4 once again equals 7. And then for our base of 3, we had 4 plus 1 gives us an exponent of 5, and 2 plus 4 gives us an exponent of 6. So again, when we're multiplying like bases, the exponents are added together because that's telling you the total number of the total number of factors of the base that you have. So in this next section, we're looking at using a power as an operation. So I like to say that's just raising an exponent to another exponent or raising a power to a power. So first, once again, we want to expand this and then simplify. So we're actually going to have to expand this twice. Notice this states we have 2 factors of 2 to the third. So that's 2 to the third times 2 to the third. From there, I can expand it further as 3 factors of 2 times another 3 factors of 2. And that leads us to 6 total factors of 2. So that would be our simplified form. In B, notice I have 4 factors of 5 to the third. So I have to write that 4 times. And then I can actually expand it once more by writing out these 5 to the third powers. So once that's completely expanded, you'll notice I have 12 total factors of 5, making this 5 to the 12th power. In example C, I have 2 factors of x to the 4th. So I've expanded it once, and then expanding it again, I have 4 factors of x multiplied by another 4 factors of x. And that gives us a total of 8 factors of x, or x to the 8th power. In D, I have 3 factors of 2x to the third, which I can then expand once again as 2 times 3 factors of x times another 2, and so on. So in the end, you'll notice for the base of 2, I have 3 factors of them. So that's 2 to the third power. And then for the base of x, I have 9 total factors of them. So that's x to the 9th. I could keep this as is, or since 2 to the third power is not a super large number, I could simplify that to 8, since 2 to the third equals 8. So this is 8x to the 9th. And lastly, in E, notice I have 4 factors of 4 cubed y squared. So that's going to look like this. And then expanding it once again. So in total, that leaves us with 9 factors of 4 and 6 factors of y. So once again, I'm going to ask you to pause this video and see if you can make a connection between your starting point and your ending point. All right, what pattern occurs? So go ahead and pause now. So hopefully you recognized that the exponents were actually just being multiplied together. So notice in A, 3 times 2 gives you a new exponent of 6. And you can actually kind of see how that happens when you expand this twice. So this almost goes back to the product rule. And thinking about up here, this is 3 times 2 to give us an exponent of 6, whereas once we expanded it once, that represents the product, and that would become 3 plus 3. Well, 3 times 2 is the same as 3 plus 3. Just like in B, 3 times 4 is 12, but when we expanded it, 3 plus 3 plus 3 plus 3 is also 12, because that's the same as 3 times 4. Notice in part D, so this base of 2 actually has that invisible exponent of 1. So I multiplied 3 times 1 to make this 2 to the third power, and then 3 times 3 to make this x to the 9th power. Lastly, we're taking a look at one more operation, and that's quotient. So that's where we're dividing exponential expressions with like bases. So notice in part A, I have a base of 2 and a base of 2. So once again, first I want to expand this before I simplify. So 2 to the 4th is 2 factors of 2 divided by 2 more factors of 2. Well, hopefully you remember that when you're dividing one quantity by itself, that is equivalent to 1. So 2 divided by 2 is 1, and that occurs one more time. So in the end, this becomes 1 times 1 times 2 times 2. But we don't even need these 1s since they don't make a difference. So this is just 2 times 2, simplifying to 2 squared. In part B, we have 5 factors of x divided by another 3 factors of x. So how many pairs of x divide out? Well, 1, 2, 3, leaving us with x times x, aka x to the second power. In part C, we have 10 times 7 factors of x divided by 2 times 2 more factors of x. So as you can see, the 2 pairs of x divide to 1. So we're left with 5 total factors of x. And then this is simply 10 divided by 2, which is 5. So the final simplified version is 5 times x to the 5th power. In part D, we have 3 times 6 factors of. So then 4 pairs of y divide out. So we're only left with 2 factors of y. And then 3/12. Well, that's not a whole number, so we can simplify that fraction as 1/4, or we could write it as a decimal value, which would be 25 hundredths. Or we could even write it as y squared divided by 4. All 3 ways work. And lastly, in part E, notice we start with 5 factors of 2, or 5, and then multiplied by 4 factors of x, and 5 factors of y. We are then dividing by 2 more factors of 2, 3 factors of x, and I'm just going to shift that over. I'm not changing the quantity, I'm just lining up the bases, and then 1 factor of y. This way you can see how 2 divided by 2 divides out 2 times, and then x divided by x divides out 3 times, and y divided by y divides out 1 time. So we're left with 3 factors of 2, making that 2 to the 3rd power, only 1 factor of x, and 4 factors of y. So I could write this as x to the 1st, or I don't have to write that exponent at all because it's implied that it's to the 1st power. So one more time, go ahead and pause this video, and I want you to think about how does your starting point relate to your ending point each time. Notice your bases are going to stay the same, but what happens to the exponent? So hopefully you recognize that the exponents are actually just being subtracted from each other. So for example, 4 minus 2 gives us a new exponent of 2. 5 minus 3 also gives us an exponent of 2. Over here, we had 5 minus 2 for the base of 2, giving us an exponent of 3. 4 minus 3 for the base of x, giving us an exponent of 1. And 5 minus 1, giving us an exponent of 4 for the base of y. And this is actually directly related to the products that we looked at above. We said when we're multiplying like bases, we add the exponents. So now if we're dividing like bases, we're doing the opposite, since dividing is the opposite of multiplying. So instead of adding the exponents, we are now subtracting. At this point, I would like you to work on the practice questions. Notice I did fill quite a few in for you, so use those as a reference, but also use these notes as a reference.